before I start, let me briefly introduce myself. So my name is Cyril. I'm working for Porsche. We are working on a big code base. We are roughly 30 teams, 105 iOS developers contributing into it on a daily basis. And our beautiful application is talking directly to the car, and that's why security is a big topic for us. And past 4 years, I was very much interested in iOS security, reverse engineering, and all the things you can break on jailbroken device. So here you might see a couple of Porsches, but what I see, in fact, are test devices. All right, so before we start, so we need an app. And we need some hands-on. So today we're gonna be reverse engineering Dviba. Dviba is my own app, purposely developed for those demonstrations. So it's called Damn Vulnerable Banking App. And now let's get some action going. So here you can see Dviba. So that's running here on my jailbroken device. So this is this is iPhone X running iOS 14, jailbroken with Uncover. So I have a full root jailbreak, and that allows me to inspect iOS in very depth. So here, the first view, you can see my shopping list. So this is my account. Here, I went to Aldi, I went to Rewe, then I stopped at Stuttgart and bought a 911, like classic shopping week, yeah, and so on. So for today's demonstration, we're gonna focus on a couple of features that the Dviba showcase. So one of the first one is send money. So this one is on a jailbroken device, and since it is a banking application, so it very much also have to check if the device is jailbroken so that it can prevent running such features on jailbroken devices. So second, what's gonna be in our interest today is shared with a friend. And share with a friend, here you can see, already here you can see, so share with a friend. The way how it got loaded is basically like non-native view. And like who here has a manager who loves to develop like non-native views because it saves time? Like I do. Everybody thinks it's much easier. Well, it's not. And today we're gonna actually focus on this feature together with some others along the way. So that was the introduction into Dviba, but now we can already go into terminal. So the first thing I need to do right now is actually dump the memory, dump the application's memory into a binary, so I can't just get it from App Store because that would be encrypted and that wouldn't help me. So in order to do that, I'm actually running a Frida server on the device. So Frida server here lists basically the applications that are running there. So here we can see Dviba. So with my script, I can now dump Dviba directly from memory, so it will be decrypted into the binary. So now we have the Dviba here, Dviba IPA. So now we have to move it to zip, then we're gonna unzip it. And now we have the payload, so we're gonna go there, we're gonna open it up, and here we have Dviba. So here it goes. Here are some things that I'm not very much interested in for today's presentation, but here we have the Dviba binary, so that's gonna be our interest. Here we have frameworks, also out of scope for today, but out of curiosity, here we have iOS Security Suite. So that's an SDK that implements loads of security features, so highly likely the app is using it for the other security enhancements. Here we have Realm Swift, here we have a TrustKit. TrustKit will highly likely provide the SSL pinning, so we are talking about banking app, so this should be like as secure as possible. Then we have here package info, also not that interesting, but we have here also info plist, and this actually has some interesting information for us for today's demonstration, and that's basically the bundle URL schemes. So we can see that this app actually handles deep links, and that's also something that we're gonna work on with later on. With no further ado, here is like share ideas. That's an HTML that looks awful a lot like the feature that we just saw in the application itself. Then, since we just dumped it from memory, then we have also the application's bundles and all the resources it has. So here we can directly open Z. Z is my new mate. There is awesome browser, by the way. If you look for switching from Visual Studio Code, then I would recommend this one. Then we have style here, which is not interesting for us, but we have also script here. And this is something we're gonna focus on right now. So this is a JavaScript, obviously. Sorry to showing JavaScript, but we have to go through it in order to go to the runtime later on. But here we have 4 functions, essentially. So we have inject name, we have a set name, we have a get token, and we have an update token. And here is like some boring HTML, which is like super simple just for the demonstration. And here we have a on-click set name. So let me show you the feature one more time. So we're gonna go there, share with a friend. So here you're just gonna set a friend's email address. So for example, mine. And when you press send, it's just gonna display it here on the view. And on the background, it's gonna talk to the server and then probably send it to that email address and validate it and so on. So not so much interesting for us. But what's interesting at this point is, if you're gonna have a look at the JavaScript, then here we have the set name. So that's what we just experienced. So we have here the invitation sent to the email which we actually inputted into the input field. And we have the get token. And then let's have a closer look on the get token. So I'm gonna make it a bit bigger. And here in the get token, we have a constant, so data, and then action, get token. And then here we have the window, WebKit, message handler for iOS, post message with the data. Data basically calls the get token. And now, like, we already know what this means. So we are now in the iOS context. So this is basically the IPC, inter-process communication between the WK web view and the main application thread. And, or main application process, sorry. So at this point, this is actually brilliant by like Apple and Android because they did the same. So WK WebView runs in isolation from other processes. And the way how your WK WebView talks to the main process is via IPC. So even if we would exploit something in JavaScript in a native built-in app, we wouldn't be able to go to the main process of the application. And that's like really, really secure, and that's awesome. And that's exactly what UI WebView was missing back then. But now like the security of the browsers and also inbuilt WK WebViews have improved tremendously. However, here we see that we have the post message, and we see the update token. So update token, what I can imagine right now the app is doing is that like I'm calling the get token from JavaScript, and I'm gonna receive the token via the update token function from the iOS main process. And that's exactly what I'm interested in, because at this point I might be able to override the update token function and like ideally send the token to my own server, such that I can work with it later on. So let's give it a try. So exploit 0. So we could basically insert into the text field simple alert, which would like call the alert, and then we would have a look if it's prone to the executable, to executing the injection. However, here we can already see that the set name has just like plain inner HTML. That's why it's going to be vulnerable for those injections. However, here is input. So this basically, or this variable is just appended to the string. So at this point, like the alert wouldn't work because we injected there, but there is nothing that would call it, right? But what if we try to wrap it up over a script, and then we're gonna inject the script, we're gonna place in the alert, and the alert should then display the hello world, or hello there. So let's give it a try. So I'm gonna let the view load one more time. Here is my script alert. I'm gonna copy that, paste it in, and nothing happened. So that's disappointing. But like, why nothing happened? So we actually successfully injected the script into the WK WebView, into the HTML, and into the JavaScript as well. So it is essentially there, but still there is nothing calling it, because this is just a script, but we also need to call the script. The page is already loaded, so all the hooks that were calling something are already gone. So that's a pity. But would be something there that we could basically tell to call it for us? And the answer is yes. So what if we inject image? We're going to edit source. We're going to edit onload. And onload, we're going to basically fire the alert. Now we have basically the trigger. And we can inject into the HTML the image itself, which will then onload, fire the alert. So let's give it a try if this is going to work. So I'm going to load the view one more time. We're going to go check exploit 2. Paste it in. And boom, and we have hello there. So at this point, like we successfully achieved like very first injection, right? So we basically injected JavaScript into the WK web view, and it got shown to us. So this is already like super cool because now we have things to play around with. And now let's like see if there is something we could do about the get token and update token, because that's essentially what I'm interested in right now. So all I want to do is to call the get token and somehow like swizzle the update token so that I get the token, and maybe I would be able to display it in the alert. And here comes the exploit number 3. So we yet again inject an image. We have a style display none, so it doesn't bother us. We're going to unload call the get token, and we're going to override the update token function so that instead, like calling the update token within the function there, it's going to call to our function. So here we have basically the alert, and we're going to inject the data that we received in the update token. So let's try it out. So I'm going to load it one more time. I'm going to go here, copy, paste it here, and we reveal the secret token. So this is already pretty damn vulnerable. Like, this should not happen. And obviously, like, at this point, you would be questioning, okay, but this is too simple, like inner HTML, like, why do you do it? This is like, obviously, it doesn't have any input validation. But I will show you how and why. Because this is like, when you ask Stack Overflow how to inject things into JavaScript, then the first thing that pops up is basically the inner text. And that's like, for us, native iOS developers, like, this could be a completely strange world. We are now like transitioning towards JavaScript, so those issues can easily happen and might not be caught up during reviews and so on, because this is like out of the scope of iOS development. So at this point, we know the inner HTML, display the token, but like, let's imagine the attack scenario right now. So you would have a highly likely a friend. He would hand it over to you the phone. You would somewhere store this script, and then you would, like on your server, then you would copy paste the script via his Safari, injected it here. You would take a screenshot, and then you would have his token, which basically represents his identity within this banking app, right? So that would be totally doable, but it's absolute nightmare, right? No one wants to do that. So is there something more we can develop? Now let's have a look at exploit 4. So what might be possible is to, one sec. Yeah. So this is actually one of the most brilliant pieces of JavaScript I have ever written. And I wrote awfully a lot of JavaScript, unfortunately, but this one is like quite special. So, and this took me quite a while to figure it out. So exploit 4, let me explain what it does. So now we have yet again the image source, which is going to trigger our onload. Onload will call the get token, and update token we're going to override. But instead of like now displaying it, we're going to inject yet again another image, which is like here, where we're going to basically paste the token, which you can see on the very last line on the bottom right, and we're going to inject it as parameter. Now, this took me a while to figure it out. Like, obviously, now, first thing you can imagine doing would be to just like conform get or push post to your server where you would post the token. But obviously, like the browser, even the WK web view has all the security already implemented. So cross-site scripting, so as the same origin policy would be there, and it wouldn't let you to send anything outside of the view other than the server that it was provided from. At this point, it's actually loaded from local file. So all those requests would be blocked, and that's no-go. However, here, we already proved that we have the image there, we were able to inject it in. Second, we now knew that we can get the token, and the third part, or the third piece of the puzzle is basically to get the third one, injected it in, and send it over a GET request for yet another image. Now, at this point, I didn't tell you, but I also have my own Dviba sniffing on reverse engineering. So this is gonna basically serve us the image that's provided there. So that's a JPEG. So that's yet another image of my childhood hero. And now let's go and let's try it out. Let's see what's gonna happen. So we're gonna move towards exploit 4. Select it here, copy. Gonna load the view again, paste it in, and send. Now we got the image there, and as you can see, we got the token from the a.jpg, right? Because we have it there in the URL that was serving the second view. So at this point, this is really vulnerable. So I can really conform a link, send it to someone maybe, and then they would click on it. But still, right now, at this point, this is only on the device. I can't do it somehow remotely. But if you remember, we also had a look at the info P list. And on the info P list, we had the deep link. And now, the deep link looks like this. It has a share, it has a name, and it has a variable. So is there something I could do with the variable, maybe? And the answer is obviously yes. So I could conform the exploit like this. So this looks terrible. This is URL encoded, and JavaScript escaped deep link towards the application that I built, which basically will send, or which basically on click will open the app and might get us the token on the server again. So let's give it a try. So for this, I actually have to be here. Now we can go here. And this is basically the deep link that you saw. And now if I click it, then it opens the link, it loads the image, and it got the token here. So now we got the token, and we did it via remote link, right? Yeah, thanks. But it's not all. That's not all. So now the first thing I can think of, or the first thing you should think of, is how the hell would I figure it out, the deep link, right? But that's where the binary comes into play. So now I can open Hopper. Hopper is my favorite disassembler, which I didn't pay for. And here is Dviba. And we can drop Dviba. So since we are on a ARC64, which is ARM64 processor, we're going to have here the ARC64 binary. Here is the entry point. And here, the first thing I think I could search for is can open URL. Can open, or what's it called? Yeah, can open URL. So this is the Swift UI handler, right? And now I can have a look where it's referenced from. So it's referenced from here, and this is the procedure where basically the handling of the deep link happens. So what I would have to do is to do a runtime hook into this procedure. Then in assembly, via registers, I would be able to figure it out, the parameters of the deep link itself. So we're gonna see something similar in a bit, yeah, you're gonna just have to trust me on this one. So that's how I did that, but let's move a bit further. So now we actually have the remote exploit, but is there something we could do? And let me show you what's totally possible. So here, what I didn't tell is my normal iOS 18, iPhone 14 Pro, because right now we did prove it that it works on my jailbroken device, which is ancient. But what we could do also is to open email, write to Arnold Schwarzenegger. Hi mate, click me. Then this is absolutely amazing. Click me. And we're gonna just attach a link to it. So here is somewhere link, add link. And we're gonna just copy it from here. From here. Boom, boom. Okay. Now, like, let's imagine like Arnold borrowed me his phone. And now, like, let's have a look. So if we open up the sniffing tool, then Arnold will open the email. And we receive the token from Arnold. So now we actually exploited Arnold like via email, via just clicking on the deep link. And this is like super amazing, right? We have his token right now. So at this point, I would be able to go through, like write scripts, like scrape the binary, like for all the APIs, use the token to do all the necessary calls to steal his money, and so on. But yeah, like we are here on iOS conference, so let's do it on iOS device, right, in the runtime. So what we're gonna do right now is, since we have the token, then first thing I can do is to SSH on my device. So I'm gonna open up Z shell. Yeah, what I didn't tell you is that I'm running debug proxy on 2 ports, 222 for the SSH and 6666 for the debug server. So we're gonna attach a debugger to the app, and now here in another window, we're gonna launch LDB, and we're gonna do platform select remote iOS. We're gonna do process connect to connect to the remote debugger. So this all works via USB. It's brilliant. It works like a charm. Now we are actually in the runtime of the application. So first thing I can do is to have a look at the backtrace. So right now we are in the main thread, and we are in the 6 stops. So that's basically where you landed when you press pause in Xcode. So the first thing I'm actually interested in, or like let's first like try to inject the token into the runtime of the application. So for that, we're gonna write an expression, and we're gonna do it in Swift. And the expression looks like this. So here I have the token from Arnold. And you might now question, okay, how did I figure it out? And like I have four different possibilities how I could construct this piece of code. Like this is basically like keychain injection, and then I still have the binary, so we can look it up in the binary. So at this point, I can have a look in ksec, I think it's called, under labels, ksec attribute account, attribute label, attribute service. All those are used within the app. So I would be able to figure it out from the binary itself, or I would be able to actually trace the keychain, have a look what it does on the background, have a look what's written to it, and so on. So that would be second possibility. Third one would be to inspect keychain, because it's just SQLite database, and you can see basically everything in it on a jailbroken device. So now we're gonna pray that this is gonna work out. Okay, it does something. Yeah, it looks good. Okay, now we're gonna do process detach. Because like as usual, or like as every sane developer would do, like the token is cached somewhere on the app. So we're gonna detach it from it. So that that killed our debugger. Perfect. Now like there is no change in the app. But yeah, let's try to kill the application and launch it again. And now you can see that we have already a different list of items, right? So here we have like Apple, some protein shakes, gym membership, Under Armour, yeah, looks like, oh, cigars. All right, and we got a profile of Arnold Schwarzenegger, which is like, you might not see, hardcore killer. So at this point, I'm not really sure if this was a good idea or not, but yeah, we are already in this jam. So let's try to rob him for some money. So we got his account on this device. That's pretty awesome already. And like by doing this, I like highly likely would bypass most of the security the app would implement. Like, you know, the device detection, like the, how I'm missing the word, the spoofing and all this, like, would highly likely be bypassed, because you have like already went through all the device checks, and developers might check for such things only during login. And like since we injected it into the already running app, then yeah, highly likely this would run through and would work. All right, so now like the second problem I have is now if I press send, then like the jailbroken device detected is shown, and it doesn't let me send the money to my account. So let's have a look in the binary again. So in procedures, we might search for jailbreak detection, and here is jailbroken. So this is the function that we want to bypass right now. So usually I bypass jailbreak detection before breakfast. So let's hope that this is going to work out. So what we're going to have to do is to run the debug server again. Here we're going to, I think this needs to be restarted completely. Yeah, OK. Now we're going to do platform select. We're going to do process connect. And now we have to actually have a look at the memory layout. So image list dviba, image list first. So those are all the SDKs loaded into the memory, right? So remember the presentation from Apple where they told you that you shouldn't use more than a dozen of dynamic libraries, while they themselves are using 420? Yeah, no comment. Further, you might also see that I have my own SDKs injected. So this is a SSL kill switch, which is also a dynamic library injected into the runtime, but this is like going to be a next presentation, highly likely. So here we have actually the list, but we can also do image dump sections. So this is the section of the main executable, and this is basically the page 0. And now here we have the offset. So every single binary that runs on iOS has an offset. So that's called address space layout randomization, so that the jailbreaking and like memory resolution is much harder to do. So at this point, like the offset is basically the difference between those two numbers. So we can also do image list -o-f on dviba section, and that should calculate it for us. So that's the offset. And now I have to calculate those two address points with the one here, because the binary basically is always, the binary always starts from 0, so it doesn't have the offset. So since we are now working in memory, we need the offset. And we got an address here. So now I can do breakpoint set on address, which is this one. We got a hit, so that's a good sign. And now if I show you the app again, then if I press send, I think I need to continue. If I press send, then I got a hit here. So we are in debugger. So we can disassemble the thread. Here we have the classic the classic jailbreak checks. So application CDI is here, mobile substrate check, and so on, SSHD. So that's not very much interesting for this presentation. What I need to do now are two things. I need to let the stack allocate a bit. So I'm going to go through a couple of steps on the thread, and now I can actually return thread return 0. So that's going to return from the thread earlier. And if I continue the program execution, then I'm already here. And if I tap, then I'm already in the send. But like this is iOS 14, this is like SwiftUR version 1.2 or something, super buggy, horrible, absolute nightmare to work with. And like every single key stroke would actually display the onload, and on onload I check, or the app checks for the jailbreak device detection, so I would have to do it like many times. And I'm like, as most of us developers, super lazy, so we're gonna bypass it also by a second approach. So we're gonna try to swizzle the Objective-C is jailbroken. And the way how I can do it now is basically I can inject a function into the runtime. No, what did I do? So the function will be called always false. To define a function on top level, we're going to use top level function, always false. We can now call always false, like this. That's going to return nil, aka false. And now we need to grab the address of always false, where it's located in the memory, which we actually injected. So this is the address. Now I can write Objective-C, and this is going to be the method set implementation class get class method jailbreak detection class, which we figured out from the binary here. And here we have the is jailbroken selector on it. So we're going to just replace it with the always false. So instead of this is jailbroken, it's going to call our function. And we got a hit, so this is always a good sign. So now when I continue the program execution, then it should not bother me anymore. Even if I close the window, then if I press send, then you can see that I'm no longer in the breakpoint. I can directly go into the view to send some money. So I'm going to send a grant to myself. And done. And we actually robbed Arnold for €1,000. How cool is that? All right. So a bit of a summary of what just happened. So we had to dump the binary so that we could explore it. That's only possible on jailbroken devices, as far as I know. I'm running super ancient one, but there are new ones that are also possible to run on more modern iOS systems. However, I myself have never accomplished to do that there. We then, by exploration of the resource files the app had, were able to find a vulnerability in the web view. And by the way, like the web view could be also transferred from the web, right? We could also intercept the network communication, find it there, and then exploit it like that. But at this presentation, it was here in the binary and was loaded from the local storage. Then we figured out the exploit of the JavaScript, because at this point, like even for the WK web view is incredibly secure, it's still is on the developer to make sure that the IPC with the main process is also secure. And at this point, we found out that it wasn't that case, and we were able to inject the JavaScript into the web view, which called the token, and then it got us and then we achieved to send the token to our server. Then, since we actually had everything installed on our device already, I was able to inject the token of the user into the keychain directly. If I would do it server side, I would have to figure it out and bypass lots of security from the app itself. But since here I already had it, I just used the iOS device to basically steal the identity of a user and steal his money. And yeah, finally we sent ourselves €1,000, so that's nice. And like, don't worry if you know Arnold, like I'm gonna give it back to him as soon as I see him. Yeah, so this was just one of the many examples that were already accomplished in the DVIBA. So some highlights of others, like Face ID, full bypass, also possible if not carefully implemented. Crypto algorithms, if you use common crypto, also like on the jailbroken device, you can swizzle the calls to common crypto. You can catch the algorithms. You can inject anything into the runtime. You can like dump keychain. You can bypass SSL pinning because that's Objective-C. And you can swizzle the Objective-C implementations done by Apple. That all works here and was proved by me. So if you are more interested in knowing, then I'm also offering a reverse engineering workshop. And yeah, that's it. Thank you very much.
Thank you. Thank you.
If you have any questions or interest.
Yeah. We have any questions out there? At least I didn't understand everything. Where are the mics? Yeah, we have a question over here, there. We might not be able to do all of them, but let's start with Mano. Short.
Hi.
Hi.
So this was very entertaining. I kind of left the jailbreaking scene when iOS was still called iPhone OS.
Yeah.
So I wonder, because you showed stuff working on iOS 14, I wonder how much of this stuff would work on an actual modern device running iOS 17?
17, I have no experience. iOS 16 was jailbroken as far as I know. But like I myself tried many different iOS 16 devices, tried to jailbreak them. I never succeeded, but I saw it by other colleagues who actually had them. So and it was not full root jailbreak. It was like partial root jailbreak. That means that you can't access everything, but highly likely the debug server would work because this is still in a user land, sort of, like you are still under the current user, and then you can attach the debugger to it. Like if you would be able to install the debugger itself, I can't recall, I don't remember, but highly likely like this would still be possible on iOS 16, anything above, no idea.
So since every one of us always struggles convincing the stakeholders to upgrade the minimum platform,
Yeah.
I guess this is like the #1 reason, right?
Could be, yeah, of course.
Well,
Like-
Arnold would agree.
Yeah, at this point, highly likely.
Good. I think we had a question over. Up with the hands if you had a question. Who was it? Okay, they forgot about it. Way back. Yeah, we'll do one up here first. Yeah.
Hi, my question is about jailbreak bypassing.
Yeah, sorry, I
Yeah.
didn't see you.
Yep. How would you go by doing that if the binary was obfuscated and you couldn't see the symbols?
Yeah, you like, even if it's obfuscated, here we are working on assembly level. So at this point, like you wouldn't have the symbols, right? But you can still hook into the runtime closures. So you can hook on view.did_load or on appear or whatever, and then you can go from there. And you would thread by thread try to figure it out where this dialog is displayed. And that's basically how you can figure it out. For the demonstration here, like I named it like is jailbroken, but obviously if you would want to make it as hard as possible, like this is jailbreak detection is jailbroken function should be named like view will appear, then it would be super confusing. Or like you could name it, you could obviously do the code obfuscation, but then like I would still see it here.
Okay, thank you.
Yeah. We'll do, this is the last question,
Yeah.
and then Antoine has to ask after.
Okay, thanks for presentation. Could you briefly tell,
Yeah, sorry.
so what measures could be taken, or how should the banking application be designed to prevent these vulnerabilities?
Yeah, it's very, very difficult. It always depends how far you want to go. But I always say, like, whatever you implement, they will break it. Here I'm in the runtime, and it's a client app. Like, I can break it, right? So at this point, like, I fully own the application. Like, I can do whatever I want with it. Like, with the full root jailbroken device, I can swizzle whatever I want. I can go to places like we never thought of going, and I would still be able to, or like 99%, I would be able to figure it out what you did and break it there. So on the other hand, the question is if you should prevent like running your app on jailbroken devices at all. Doesn't necessarily have to be a bad thing, but yeah, you should decide. It's a more or less product decision on like what kind of measures you want to implement. But on top of my head, like you have the debugger attachment, so you can check in kernel if your process is being debugged. So that would be something, because then it would be harder for me to attach the debugger. However, it would still be in the binary. So for me, like I would, like the code would have still some pattern which the reverse engineers would be able to figure it out and then find it in the binary, recompile the binary, resign it, run it on the device, and then attach the debugger again. So that's just one of many examples. You can check for signature of the app. You can check for all those things that you saw here if they are installed. You can check for any third-party libraries injected, and so on and so on. And it only depends how far you want to go. At some point, you probably have to say, okay, this is enough, and like you can't just prevent the users because this is a front-end facing app. Same as any web application is loaded fully with the JavaScript. You can inspect the JavaScript. Here we can inspect the assembly. You can recompile it. You can strip off some procedures here, or like reassemble the binary so that you can resign it and so on. It's just like a matter of time the reverse engineers want to spend with that bypass.
Thank you.
Good. Thank you, Cyril.
Thank you very much.